Class 9 Mathematics, Lecture 1 on Quadrilaterals. Dear students, welcome to this session of Quadrilaterals. Now, in your earlier classes, you have studied about triangles, that if we join three non-collinear points, the figure we get is a triangle. Now, if four non-collinear points are joined, then the figure we obtained is a quadrilateral. So, a quadrilateral is a four-sided figure. Now, let us discuss the different types of quadrilaterals. Now, a quadrilateral in which one pair of opposite sides are parallel is a trapezium. This pair is parallel. If we say ABCD, so here AB is parallel to CD. A trapezium in which both the pairs of opposite sides are parallel is a parallelogram. Here this pair is parallel to this and this is parallel to this. So ABCD is a parallelogram with this is a parallelogram. AB parallel to CD and BC parallel to AD. Now, a quadrilateral in which all four sides are equal is a rhombus. Here this ABCD in which all the four sides are equal is a rhombus. And a quadrilateral in which all four sides are equal and one angle is 90 degree. These all four sides are equal and this angle is 90 degree is a square. Now, a quadrilateral in which opposite sides are equal and one angle is 90 degree is a rectangle. So these are the different types of quadrilaterals. Now we have one more type of a quadrilateral, a special type of a quadrilateral in which the adjacent sides are equal. A, B, C, D. This is a quadrilateral in which adjacent sides are equal. AB equal to AD and BC equal to CD. Here AB equal to AD and BC equal to CD. So this quadrilateral is called a kite. This is a kite. In a kite, the adjacent sides are equal. These two sides are equal and these two sides are equal. Now let us come to the properties of a parallelogram. Now in a parallelogram, opposite sides are equal. Properties of a parallelogram. Now first is that the diagonals of a parallelogram divides the parallelogram into two congruent triangles. Diagonals of a parallelogram divides it into two congruent triangles. So by SSS congruency we can prove that these two triangles are congruent. This side is common. Second property is that in a parallelogram opposite angles are equal. This pair is equal to this. This pair of opposite angles is equal, and these are equal. These two angles are equal. Now next property is that if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. If in a quadrilateral each pair of opposite sides is equal, if this side is equal to this side and this side is equal to this, they are equal, then the quadrilateral is a parallelogram. Now in a parallelogram, opposite sides are equal. In a parallelogram, opposite angles are equal, and the diagonals of a parallelogram bisect each other. Next is the diagonals of a parallelogram bisect each other. This diagonal is bisected here and this diagonal is bisected here. In a parallelogram, the diagonals bisect each other, and the converse of this will be that if in a quadrilateral the diagonals bisect each other, we can say that it is a parallelogram. Now one more condition for a quadrilateral to be a parallelogram is sufficient condition that if any one pair of opposite sides is parallel as well as equal, we say that the quadrilateral is a parallelogram. ABCD is a quadrilateral. Now this side AB is equal to CD as well as AB is parallel to CD. So this is the sufficient condition for quadrilateral to be a parallelogram. So here ABCD is a parallelogram since AB is equal to CD and AB is parallel to CD. Now let us take question 10 of exercise 8.1. Question 10 of exercise 8.1. The question is, ABCD is a parallelogram and AP and CQ are the perpendiculars from the vertices A and C on the diagonal BD. ABCD is a parallelogram diagonal BD is joined and AP and CQ are the perpendiculars from the vertices A and C on the parallelogram on the diagonal BD. AP and CQ are the perpendiculars. Now show that triangle APB is congruent to triangle CQD. Now in first part you have to show that triangle APB is congruent to triangle CQD, and then second part is AP equal to CQ. Second part AP equal to CQ. Now first let us see how these two triangles are congruent. APB, we have to show that this triangle is congruent to triangle CQD. Is congruent to triangle this. This triangle is congruent to triangle APB is congruent to triangle CQD. These two shaded triangles are congruent to one another. Now here AB, let me explain. Proof will be given and to prove you have to write first and then comes your proof that AB is parallel to CD. So these are the pair of alternate angles between these two lines. If two lines are intersected by a transversal, if two parallel lines are intersected by a transversal, then the pair of alternate angles are equal. So this one pair of alternate angles will be equal. It's a parallelogram. A with AB parallel to CD, AB parallel to CD given BD is the transversal, therefore let us name this angle 1 and angle 2. Angle 1 equal to angle 2. Moreover, angle APB equal to angle CQD equal to 90 degree. This is also given. And third is AB equal to CD. Why? Opposite sides of a parallelogram are equal. Therefore, by AAS congruency criteria, triangle APB is congruent to triangle CQD. These two are congruent by AAS. Angle, side. Angle and side. So by AAS congruency criteria, these two triangles are congruent. Now in the second part, we have to prove that AP equal to CQ. Now AP equal to CQ here. Now since triangle APB is congruent to triangle CQD, since triangle, this is the symbol for since triangle APB is congruent to triangle CQD, therefore by CPCT we have AP equal to CQ. What is this CPCT? Corresponding parts of congruent triangles are equal. Triangle APB is congruent to triangle CQD. These two triangles are congruent, so the corresponding parts will be equal. Corresponding parts of congruent triangles are equal, therefore AP equal to CQ. Hence we have proved that these two triangles are congruent and these two sides are equal.